Hello class. Today we begin chapter 11, lesson number 1, and we're going to be dealing with fractions in this chapter. First lesson we're going to review a lot of fractional information or information of fractions that you should already know. So it's really more of a refresher, and then we're going to enter into the algebraic world of fractions in the lessons to come. So let's take a look on page 498, and we start off with an illustration at the top, little comic strip. Good news! The king has reviewed your case and he's cutting your sentence in half. Comes in and he actually cuts off one of the chains. So I guess his sentence got cut in half. You would expect that might have been time, but instead of hanging from 2 arms, he's only hanging from 1, which probably makes it a lot worse. Anyway, let's start reading. 1/2 is the simplest example of a fraction. One way to picture 1/2 is shown in this diagram. If something is divided into 2 equal parts, each part is called 1/2 of it. So we have a whole bar, and it's split in half, so we have 2 halves, right? Now, all of the fractions that we first learned about in school can be pictured in the same way. The fraction 2/5, for example, can be pictured by dividing something into 5 equal parts and then taking 2 of them. So we have an example here as well. We have the 2 green boxes representing 1/5 plus 1/5, and there are 3/5 that are out there, so we have 2/5. It is for this reason that the top number of the fraction is called the numerator. It's the number. And the bottom number is called the denominator. Okay, the numerator is like how many. And let's read. The denominator tells us what kind of parts, so we're dealing with fifths. And the numerator tells us how many of them. And in this example, we had 2. Now, to explain what a over b means, in which a and b are positive integers, we simply think of dividing something into b equal parts. Okay, so we don't really have a number. It's not 5 equal parts, not 2 equal parts, it's b. And what is b? Well, whatever b is. We can make b 10, we can make it 1, we can make it 100, and we're dealing with positive integers here. Okay, each part is called 1/bth of the thing. So again, if we had, let's say a 6, it would be 1/6. If it was an 8, if b were 8, it would be 1/8. Okay, and then we're going to take, and then taking a of the parts. So that's kind of like a funny way of saying this. It's, you know, a parts of a bth, you know. According to this interpretation, now a over b means a times 1/bth, right? So that's where we're kind of venturing into a different world of fractions here. Okay, 1/bth. Okay, remember we had before, we had 1 times a half, right? We had 1/2 we were talking about before. We also talked about 2/5. Okay, now what we're actually doing is we're multiplying here. Okay, this is a multiplication, and we know that we would represent this 1 times 1 would be 1/2, and 2 times 1 would be 2/5. So that's pretty much what they're just showing here. Okay, we would be able to do this because you know you would multiply the a times the 1, and you have a over b. Okay, a more general interpretation of the fraction a over b is that it is the indicated quotient of the numbers a and b. The quotient meaning we're dividing, right? By using this interpretation, we can represent the fractions 1/2 or 2/5 in a decimal form by carrying out the indicated division. We go 2 into 1, which we would then put a 0.0, and obviously it would be 0.5, so we have the decimal. 1/2 is equal to 0.5. When we also put 5 into 2, well, how do we do it? Well, we add that decimal, and we add the 0, and again, now we multiply by 4, and we get 20, and obviously with the decimal, it means it's 0.4. So we had 1/2 is 0.5, and 2/5 is equal to 0.4. As we have learned from our study of rational numbers, not every fraction has a decimal form as simple as these. The decimal forms of 1/3 and 4/5, for example, never come to an end. So we round them according to the accuracy that we want. So you can see we divide 3 into 1, it's just 0.33333, and we can go on. And if we divide 7 into 4, we get 5.17 ... And so what we're doing now is we're just looking at these examples and knowing that we can always divide. We can always convert a fraction into a decimal. Okay? Now, let's turn over to page 500 and we talk about rounding. Rounding 4/7 into the nearest tenth, for example, we get 0.6. So to the nearest 100th, it would be 0.57. To the nearest thousandth, 0.571. Now, depending upon the accuracy that we need, obviously we would choose the number. We're usually told in the problem, round to the nearest hundredth or to the nearest thousandth, okay? Because it does not make sense to divide by 0, it's obvious from looking at a fraction as a quotient and that the denominator of the fraction can never be allowed to be 0. So we know we can never allow 0 to be in the denominator. This means that if we write a over b, it is understood that b does not equal 0. Now, the idea of a fraction as an indicated quotient gives meaning to all fractions, not just those consisting of positive integers. We can do -2 over -5. Now, what's a -5? Like if we really thought, okay, I have a pie and I'm going to cut it into -5s. It wouldn't make sense. But when we think of it as a quotient and we think of it as the math that we already know, we can divide negatives and positives. We already learned that. So we can now understand what -2 over -5 is. We would, all right, now we could never divide something into -5 parts, but we know that first off we have two negatives, right? And when you divide two negatives, it's equal to a positive. Right, so we're able to understand math not just in the fractional form but also in the decimal form, and it makes a lot more sense when we see it that way. Now, so let's just continue reading. For example, a fraction such as -2 over -5, for example, has meaning even though we cannot divide something into -5 parts and take -2 of them. It means the number -2 divided by the number -5. Because the quotient of two negative numbers is positive, then we can just simply write it as 2/5, which is 0.4. Now, reasoning in the same way, we can show that regardless of whether a and b represent positive or negative numbers, right, we can write this. We have -a. All right, let's say we have a -a over -b. Well, we know that's equal to a positive a over b. Why? Because the negatives cancel out. I know you kind of like using that. We can also say that a -a over b is simply equal to the negative of the entire fraction. So it will be -ab. Excuse me, -a over b. And we can also say that when we have positive a over -b, well, it's the same thing. It's going to be -a over b. And why is it? Because we know that when we're dividing and we have one negative, okay, so we're dividing a positive and a negative, we know we're going to have a negative answer, right? And depending upon which one's negative, doesn't really matter, right? The numerator, denominator, or when we're doing our division, you know, we're doing this, okay? If it's -a into b, that would be negative, all right? And if this were positive and this were negative, it would still be negative, so it doesn't matter. So regardless, the answer is always going to be negative. Now, let's take a look. This figure shows the fraction 2/5 and 4/10 represent the same number. Now, let's take a look here. It looks like this would be like, let's say, like a ruler, all right? And let's say this were 1 inch, though it's really not 1 inch, but it's divided into 10 parts, right? All right, so we have this one long distance here, and then you have all of these little slashes in there, and each one of those, if you count them, you'll see that it represents 10 equal parts. Now, why is it that 2/5 is equal to 5/10? Well, if you were to divide the same area just by 5 parts, and you could take a look at the line sticking out above, notice that the little slashes are sticking above the line, and there's 5 of that creates 5 equal parts, right? So if you count over 2/5, it's the same as 4/10. Now, let's continue reading. Fractions that represent the same number are called equivalent. What fractions other than 4/10 are equivalent to 2/5? Well, let's think about it. It could be 6/15. Well, why is that? Well, if you multiply 3 times 5 and the denominator, you get 15. All you'd have to do is multiply 3 times 2, and you get 6. So we know that these are equivalents. The others are 8 twentieths. 8 twentieths, if you look at 4 tenths and you simply multiply the numerator and denominator by 2, you'd have 8 twentieths. And you know that 2 over 2 is equal to 1, so you haven't really changed the value. You're just simply changing the fraction, the number of pieces. It's sort of like taking a pizza pie, right? And you have a big pizza, and let's say, oh, there's 4 of us, we're going to cut it into 4 parts, right? So everybody gets 1/4. Oh, but 4 friends show up. Well, we're going to have to divide it. Oops, sorry. It's not a really good line. I think we really need to redraw that. It'd be tough to even cut a pizza that way, but all right, so let's say you cut it into 8 parts now, right? So now you have 8. So now if I'm still going to eat 1/4, instead of eating 1/4, I would eat 2 slices. That would be 2/8, right? So, and they're equivalent. I'd still be eating 1/4 of the pie. But again, we have 8 people showed up, so I'm only going to get 1 slice, so I'm actually getting a lot less. So let's read on. In fact, I'm sorry, we had the negatives here as well. Negative 2/5, negative 4 tenths, negative 2 over 5 over negative 5, negative 4 over negative 10, and negative 6 over negative 15. These are all equivalent, depending on where the negatives are, and it ultimately, we're really looking at maintaining multiplying the fraction by 1, and that's all we really did here. We're multiplying the fraction by 1, but that 1 is being represented by 2 over 2. It's being represented by 3 over 3. Okay. Now, in fact, any fraction formed by multiplying the numerator and the denominator by the same number, other than 0, can't do 0 because then you'd have a 0 on the denominator, so you're not allowed to do that. So anything that when any fraction formed by multiplying the numerator and denominator of a fraction by the same number is equivalent to it. So in general, if n is not equal to 0, we can then say, and I'm going to write it down over here, you're looking in your textbook, n over a over n over b is equal to a over b. And we know why, because n over n cancels out. But that's the reason why we're doing this, because you will have to factor. You'll be able to see, for instance, you have, let's say, 12/15ths, right? And if you wanted to simplify that, well, how could we simplify it? Well, we know that this is 4 times 3, right? And this is 5 times 3, okay? So 3 over 3, those would be my n's. I'd get rid of it, and I'd have 4/5, right? So let's continue reading. It also follows from this equation that we can divide the numerator and denominator of a fraction by the same number other than 0, okay? If a number is a factor, if a number is a factor of both the numerator and denominator of a fraction, this procedure is called reducing the fraction to lower terms, and that's basically what we just did here with 12/15ths. Dividing by the greatest common factor results in a fraction that is being reduced to lowest terms. For example, dividing the numerator and denominator of 24 over 36 by 2 results in an equivalent fraction of 12 over 18. Now dividing both by 12 reduces 24 over 36 to its lowest terms, 2 over 3. And again, when we talk about dividing, think about it. What we're doing here is taking 24 over 36, okay, and we said we would divide it by 12. So what happens? I'm going to divide this by 12. And this by 12. Okay, now this looks a little bit strange, but just bear with me, because we know that 12 into 24 is going to give me 2, right? And 12 into 36 is going to give me 3. Okay, so we were dividing, and we created this number right here, 2/3, because again, these are the n's. These are the these are the factors that cancel out, right? So we ended up with 2/3. And then we have some examples here on, let's say we write a fraction that is equivalent to 3/7 and has a denominator of 28. Well, because 28 is equal to 4 times 7 we multiply both the numerator and the denominator by 3/7 by 4. So if you take a look here, we have 4 over 4. We're multiplying 4 times 3 and 4 times 7, and now we have 12/28. And again, we look at our NA over NB. You know, our 4 over 4 is the N. Really, we're going in the opposite direction. We're making this. We're not. Excuse me. We're normally going to go in the opposite direction. We're going to reduce. But really, this is just an exercise to show that you can represent 3/7 as 12/28. They're equivalent. Now, we're going to go the other way here. Is reduce the fraction. In example number 2, reduce the fraction 102 over 12 to lowest terms. Now, because 102 is equal to 2 times 3 times 17, and 12 is equal to 2 times 2 times 3, we know that their greatest common factor is 2 times 3. We learned that in a previous lessons or previous chapter. So we have 2 times 3 on each of these, which is basically 6. We know that. So we're dividing both the numerator and denominator by 6. If we look at the second line, and we have 6 times 17 and 6 times 2. So 17 over 2 is the lowest terms because the numerator and the denominator have no common factors other than 1. So you can go ahead and do your lessons. Again, this is a lot of review of fractions that you've learned in the past, and you shouldn't really have too much problem. You're going to get challenged a little bit to remember this, and really it's a foundation. When we get into lesson number 2 is when we're really going to start doing this more algebraically. So it's the end of this lesson.